Hi everyone, in this video I will work on an exercise of DIgSILENT to create power system elements step by step from starting to finish. To open the exercise from the main menu list, we must open the help menu. Then select the option as Start Tutorial. As you can see, the Tutorial Manager windows appear now. From Start, select Exercise 2, then click on Execute. Now a PDF appears related to this exercise. There is also a single line diagrams in gray color visible in the background that we are going to draw our system on them. From the Data Manager tools, you will see that the project is open as Tutorial Exercise 2. If you click on plus sign, you will see the library, network model, and also study cases. The first step to draw a power system is to create a substation. So from the drawing toolbox, select single busbar system. By left-clicking on each point of the system, the new busbar is drawn. Then the busbars must be connected with transformers. So left-click on the icon to winding transformer in the drawing toolbox. Left-click on the position where you want to put it. Then left-click on the upper terminals and the detailed graphic of this substation is open automatically. Connect the transformer to one bay by clicking on one of the market breaker terminals. As you see, the transformer is now connected graphically to the terminal at that position. Then left-click on the middle busbar to make the second connection. Again, the detailed graphic is open automatically and connected to one of the breaker terminals as before. Let us do the same thing for the middle and the last busbar. By left-clicking on your transformer and hold down the mouse key, you can change the position. If you want to resize the busbars, left-click on this small square, then drag it to the left or right. To zoom our drawing, left-click on the zoom in icon. Then draw a square where you want to zoom it. The selected square will be zoomed when releasing the mouse key. The zoomed graphic area can be moved by using the hand tool. Then right-click on your mouse to exit the hand tool mode. To see the whole area again, click on Zoom All icon or click on Zoom Back. The next thing to do is creating single port elements. These are the power system elements that are connected to only one terminals, such as generators, motors, loads, external grids, and etc. For this drawing, we need two asynchronous machines. So click on a synchronous icon, then left-click on here and connect it to this busbar. Then connect it to one of these breaker panel by clicking on one of these breaker terminals. Connect the second machine to this terminal. Apply the same steps as before. The last connection to do is the external grid. So click on the external grid icon, then left click here and connect to this busbar. Left click and finally left click on one of these breaker terminals. Now your drawing system is completed. If you want to flip these asynchronous machines upward, just left click on asynchronous machines click on Flip at bus bar. To bring it back to its original position, click Undo from here or hold down Ctrl Z. The next step that I am going to show you is about how to enter the parameters. Before doing that, let us hide the background because it is not needed anymore. Click on the Show Layer icon. A new graphic layer window appears. The background layer is in the visible parts. To put it in the visible list, click on this button, then click OK. Now the background is removed completely. Let us enter the parameters for these power system components. If we look at the tutorial, the editing power system for the first bus bar must look like this. Name D1 underline swap, type 33 kV, system type AC, phase technology ABC, line to line voltages 33 kV, and usages bus bar. Okay, let's write them on our first bus bar system. Left click on bus bar, then click on edit data. The new editing window open. Change the name to D1 underline swap. For the type, left click here and choose the selected project type option. Then select the bar 33 kV. Press OK. Change the nominal line to line voltage to 33 kV. In order to edit the substation, click on this blue arrow button. Then change the name to station 1. For the short name, enter S1. Make sure that the nominal line-to-line voltage must be 33 kV. After that, click OK. Again, click OK. For the middle substation, let's look at the edited components. As you see, the edited components for the middle substation is as following. Name D1 underline L1A, type bar L1 kV, line to line nominal voltage L1 kV. Name of the substation is station 2, short name is equal to S2. Okay, let us apply it to our system. Double click on the middle bus bar, change the name to D1 underline L1A. Click here, then select type project, choose bar L1 kV. Click OK. Change line to line nominal voltage to L1 kV. Name the substation as station 2 and short name as S2. Then close all the windows by clicking OK. Let us look at the components of the lower terminals. The lower terminal is at 3.3 kV. Name is equal to D1 underline 3.3 kV. Type is equal to bar 3.3 kV. Nominal voltage is equal to 3.3 kV. Name of the substation is station 3 and the short name is equal to S3. Okay, let us apply to our system. We just follow the same steps as before. Now let us edit the transformers. As we already know, the nominal voltage for the first bus bar was 33 kV, L1 kV for the middle, and 3.3 kV was for the last bus bar. So we can say that this transformer should have 33 over L1 kV and this one must have L1 over 3.3 kV. Let us look at the tutorial. Editing for the top transformers. Name T1 underline 33 over L1A, type project type TR220 semicolon 33 over L1 semicolon 10. Automatic tap change is disabled and the top position is set to 0. Let us go back to our system. Double click on the top transformer, name it T1 underline 33 over 11A. Left click here to edit the type, then select project type and choose TR2 20 semicolon 33 over 11 semicolon 10 and click OK. From the load flow, check that the tap position should be 0 and the automatic tap change should be also disabled. One more thing to tell you, if the high voltage and low voltage sides of the transformers are not connected correctly, press the flip connection button from here, then press OK. Do the same steps for the lower transformer. The editing of bus bars and transformers are completed. Let us edit external grid. Double click and a new window of external grid appears. Name it as transmission grid. It doesn't have any type. In the load flow, we have three types of buses in our power system: PQ, PV, and slack buses. PQ buses are specified as real power P and reactive power Q. It can also called as load bus. In this type of bus, the generated real and reactive power are assumed to be 0. This is used to find the bus voltage and an angle. PV bus and voltage controlled buses are specified as real power P and voltage magnitude V. This is also called as generator bus. Slack or swing bus. Slack or swing bus is used to balance the active and reactive power in the system. The slack bus works as an angular reference for all other buses, which is set to 0 degree, and voltage magnitude is also assumed to be 1 per unit. In traditional load flow calculations, the slack node associated with a synchronous generator or an external grid carries out the balancing of power in the system. And in this system, the slack buses preferred to use. The angle is 0 and the voltage set point is also 1 per unit. In the VDE or IEC short circuit power must be 10,000 MVA and R over X ratio must be also 0.1. Now let us turn to a synchronous machine. Double click and name it as ASM1A. Type, select project type, then choose ASM 11 kV 5 MVA. In the load flow, enter 4 MW or 4 megawatt for active power, then click OK. Do the same steps for the other synchronous machines. Now our system is ready to perform a load flow calculation. You can start it from the main menu, click on calculation. Then select load flow, or you can directly click on calculation load flow icon. In the calculation method, select AC load flow balanced positive sequence. Then disable all the reactive power controlled options if they are enabled. And temperature dependency is set at 20 centigrade. No need to change the others. Click on execute. Now you can see that the color of our bus bars are changed. And you can also see the calculated results in each of these boxes. You can zoom it to see better. If you put your cursor on the box, you can see the active and reactive power and also the current passing through our system. Now check the result of our load flow calculation with tutorial. Let us put them side by side to see them better. Real power is 5 MW for both. Reactive power is 2.1 and this is 2.05. I will talk about them why there is a few different. And in bus bar the voltage is 33 and 1 per unit for both of them. If you put your cursor, you see a big UI which shows the magnitude of voltage in terms of volt, and a small u represent per unit, and this also show the angle, so we can see the same result as we expected. By right clicking on each of these result box, you can also select the other parameters and edit them. If you want to see power factor, select current power factor. As you can see, the format is changed. Or you can also see the fault clearing time. Let us put it in the branch flow. You can also format the two winding transformers. Let's select current power factor. As you can see, the format for both of our transformers are changed, but the others are not changed. That is the way how to change the format. You can do the same thing for motors, but for the node elements, you choose line to ground voltage angle or line to line voltage angle. To understand how the format of these result boxes managed and edited, it is important to know the nature of the power factory result. In these result boxes, there are results for branch elements and node element, which are different from each others. For example, the components like external grid, cable, transformer, generator are each element, and the bus bar, as you see here, is node element. Inside of this result box, I want to see some other parameters, so right click on them, click on edit format. For each elements, a format window will appear. In this dialog, there is an input mode. Click it and there are two states, user selection and format editor. It is usually put on user selection. As you see, there is a table that real power is represented as MW, reactive power is as MVAR, and current as KA. In the result box, you see real power has two decimal numbers, reactive power 1, and the current has 3 decimal numbers. And we can change the numbers from here. Let's make all of them 2. Click OK. Now all our parameters have 2 decimal numbers. Now if you want to add some other parameters, just right click on the third line. If you click on insert row, an extra empty line will open on top of our current line, and our current line will move to fourth line. If you insert append rows, a new empty line will open at the lower. And if you select append in rows, it will ask you the number of lines that you are going to insert. If you want to delete these extra lines, right click and delete them. Now I want to insert a new parameter, double click here and a variable selection window open. Since we are calculating the load flow, we will see here only the load flow parameters. From variable set, we can select different variables. We are not going to work on this variable, so keep it on current, voltage and power. Let us add cosify. From here, enable it. Then click here to add it in the selected variable list. Then click OK. You can observe the change in the result box that the power factor is added. Let us add voltage magnitude as well. Right click, choose edit format and right click on fourth line, click on append rows, then double click on fifth line and from the variable set select pass results. Now you can select voltage in terms of per unit or magnitude. We have line to ground voltage and line to line voltage. Let's select line to line voltage magnitude. Now there are real power, reactive power, current, cosify and voltage magnitude. We can also do the same thing for our bus bars. Right click, entering to edit format, create a new line, double click. For example, we can choose generation active power. As you can see, the generation power on this bus bar is 0 because we don't have any generation on this bus bar. In addition to these parameters, I want to see some other parameters such as type of transformers, rating, power of transformer, and etc. For example, here I have this transformer with rated power of 20 MVA and voltage ratio of 33/11 kV. I want to see inside of this result box type of these transformers. Right click, enter to edit format, double click on N local bus. From here, let's find the rated power transformer. Every parameters in the DIgSILENT has some special name. Let's look at the name first. Double click on transformer, then click here. If you put your cursor on this, you will see the parameter name, that is strn. Write strn in the variable name. The list will look empty and there will not any parameter as strn because in the load flow we will see only parameters related to load flow. So we must select basic data which contains transformer parameters. Here if you enter the type parameter from the available variable, can select the parameter strn. Double click, then click OK. Now you can see strn or the rated power of transformer. As a result, from the edited format, you can add or remove parameters. The final thing that I am going to show you is how to calculate short circuit. To calculate short circuit, we can use calculation from main menu, short circuit. We can also calculate it in more simple way. Just click on short circuit icon on the main toolbars, and we can directly calculate it from the single line diagrams. In general, we can do two kinds of short circuit analysis. One is AC short circuit analysis and the other is DC short circuit analysis. Usually in power transmission and distribution, we use AC circuit. Click on short circuit icon, the short circuit dialog box will appear. Method: DIgSILENT provide the following methods for short circuit calculation. VDE0102 is the German standard. IEC 60909 is the international IEC standard. ANSI is the American or IEEE C37 standard. Complete is the superposition method, considering the pre-fault load flow results. Usually in this software, the complete method is used, and these are also the DC standard. Fault type. We have many types of faults, such as three-phase short circuit, two-phase short circuit, single phase to the ground, and the others. For this system, let's put it in three-phase short circuit. From here, we can create maximum or minimum short circuit. Usually it is put it on maximum short circuit current. From here, we can determine short circuit duration. For example, break time or fault clearing time. We can also determine the fault impedance by using resistance or reactance. Fault location. It is an important discussion, and this represents where fault can occur, and the selection options are at user selection. In this case, the fault location is to a single terminal, busbar, line, range, or to a selection of busbar. At busbar and junction internal node, it is for every terminal in the network. A short circuit calculation is carried out independently. At all busbar, this is also for every terminal in the network whose usage is set to busbar. Usually it is put in the user selection. There is also an advanced options. In this video I will not talk about. Later in the next video I will talk about this advanced option as well. And click on execute to calculate short circuit. Let's zoom our system where the short circuit occurs and how it can work. The short circuit occurs on each of the busbars. If you put your cursor on this result box, you see that there are IKSS, IKS, and IP. To know what kind of currents they are, right click on this result box and then click on edit format for short circuit. So in this table you can see the description for all of them. For example, IKSS is initial short circuit current, and the same thing for IKS and IP that you can see the description here. You can also change or add different formats, the same as in the result box of PowerFlow. If you want to see the fault on a specific busbar, right click on that busbar, then select calculation short circuit. As you see in the user selection part, the busbar is selected. Now, as you see, the fault is only on bus D1 underline 11A. If you want to see all the reports, click on maximum output window icon, and you will see all the results. That is all for this tutorial. I hope it was easy to follow and helpful. Thanks for watching. If you like the video, please subscribe our channel.